Hey, it's Trip here from the 87th. This video is about the Engine Airstart procedures in BMS 4.33, and the information is current as of update 2. So before we start, just mention that anytime you have an irregular or emergency operation going on, the first thing you want to think about is flying the airplane. So get control of the airplane, and what that means to us possibly is turning out of harm's way. I mean, if we're across the FLOT and we're headed toward a SAM threat circle, obviously we don't want to go into that while we're trying to restart the engine. So turn the airplane toward a safe direction. If you're low altitude and terrain's a factor, you want to roll the wings level and zoom up and climb up as high as you can to put as much altitude below you. Altitude below you will give you more time to get the air start accomplished. So those are a couple of considerations. Analyze what's going on. Initially, you're not going to know if it's an electrical failure or an engine failure of some sort. So try to figure out that from the indications, and we're going to go through those step by step here in just a moment. And then take corrective action. So the corrective action that we're going to be taking is I'm going to shut the engine off using the fuel master switch, and then resupply fuel by turning the master switch back to the on position. I have that programmed into my HOTUS. I would never have that in there normally, because I could accidentally hit that button and flame the engine out at the at a wrong time. So, but for the ease of use of this video, I have it programmed in, since I'm going to be using this switch a lot. Another thing that I have programmed in is the throttle idle detent. So normally when the throttle's at idle, if we put the mouse cursor over this lever on the throttle, we get a green mouse cursor indication. Now if we left click it, we'll activate the throttle idle detent function. But we're not concerned with being at idle for engine air starts. We want to be in the mid-range, up in this area here. So if I try to put the mouse over this lever, I get nothing. The green cursor occurs at this position. It's on the sidewall of the cockpit. A good way to locate it is push the throttle up far enough to where you see this red guarded backup engine control cover, and then just come up a couple inches, and now when you left click, you'll activate throttle idle detent. The other thing that I have programmed into my HOTUS for ease of use in this video is a way to clear these fault messages in the HUD and extinguish the master caution light. So although I won't be clicking on any of the buttons here, you could use the fault acknowledgement button too to do the same thing, but I'm just going to use my HOTUS. Now the proper way to do it is when you get fault lights here, you come down to the HSD and you click on this test OSB and then the clear OSB, and that'll clear the faults messages here and extinguish the light. Alrighty, let's see. Back to normal. Alright, so that's the setup. So the first thing I want to talk about is the things we lose when the engine quits. So I'm going to initiate an engine failure by opening up that fuel master switch. It's in the off position, and if I pause the sim right here, the very first thing I notice, if you happen to notice it, is the decrease in the engine noise if you have that set high enough. Now in the heat of battle you probably won't be hearing that, but you do see some engine RPM decay, and let me see if I can get a better picture of that for you. There we go. So the normal flight idle is 70%. So if I let the sim run a little bit further, then I see that the idle is going down below 70%. And hey, the lights went out. I had the cockpit floodlights up, so that's an indication if you have those on. I also see that the, let me get this picture here. I also see that the nozzle went to the full open position, up to 100%. So that's kind of telling me that I got something funny going on with the engine. Now other indications are, when I get this main generator fail light on, the indications are I lose HUD information here, and I also lose my VHF radio. And at some point this ICP is going to be inoperative also. So let me let the sim run again until we lose the standby generator, which is right there. Now notice that when I lose both the main and the standby generators, that the EPU starts. It'll automatically start in that condition. It also automatically starts when you lose both A and B hydraulic pressure. When they go below 1,000 pounds, then you get the EPU automatically starting, but I don't think that's simulated in Falcon. Alrighty, so up front here, what we've got is the total loss of the MFDs. We've lost the DED, and we've lost the ICP. Temporarily, until the EPU gets spun up, we've lost HUD indications, but it's only a matter of seconds. We've got an engine fail problem here with a master caution light. We look down on the panel, we've got an electrical system fault indication. So we've lost generators here. Alright, I'm going to let the sim run, and let's listen to Bitch and Betty tell us we have a problem. Alright, so now we got the HUD back up. We can get rid of that warning by canceling it. Now when we get below 20%, can you see that there? Right about there is where we get another indication that we have low hydraulic and oil pressure. So again, we can cancel that. So what we want to do in this case, we have the altitude. We want to pick up about 250 knots minimum. It's a good glide speed. It's good speed for maneuvering in case we have to make turns away from threats or whatever. Alrighty, I'm going to put the sim on pause and talk about, those are the things we lost. Let's talk about some of the things we still have. Since the EPU is running, we have flight controls through the A hydraulic system, so we can fly the airplane. We have speed brakes. We have an ADI if we're in instrument conditions. We have pedostatic instruments, airspeed. The altimeter is degraded somewhat because of loss of inputs, but we still have it operating in the pneumatic mode, so it's accurate for altitude indications. The master caution system, the light is on. We still can jettison stores if we have to with the push button here. And of course we have the RPM indicator. The JFS, the jet fuel starter system works. It has a runtime of 4 minutes each time it is engaged. Okay, yeah, the UHF radio, we can come back here when we get everything squared away and we're into the start process and the RPM is spooling up and we're just waiting. We can come back to the CNI switch and we can flip that to the backup position, and the mode switch on the UHF backup radio control panel, we put that in the guard position, and now we can talk to the rest of the world using the normal UHF push to talk button in the cockpit that you use. So we can let somebody know, who we are, where we are, what happened, and then the next important thing that you want to mention is to tell them to stand by, because you don't want to be playing 20 questions when you're trying to get the engine relit at low altitude. You just don't have time to answer questions, but at least we've let somebody know that we have a problem and that we may need some help. Alright, so that's what we've lost, that's what we've got, and when we start the sim again, we're going to use the JFS, or jet fuel starter system, to start the aircraft. Now to use the JFS system, you need to be in a speed range of 250 to 400 knots and below 20,000 feet. You will not be able to get the JFS switch to start, and I need to come off pause, pull the throttle back. You won't be able to get the JFS switch to the start to position if you're above 20,000 feet. Now, there's a big problem if you try to do that. If you jump the gun a little bit and you're not thinking, you don't get below 20,000 feet, and you activate this switch with a right click, even though you're right clicking it, in this situation the EPU is what's powering the airplane, electronically and flight controls. Over here on this side panel, you've got a hydraulic pressure A and B. You've lost the B hydraulic system, and it's the B hydraulic system that recharges the accumulators, the hydraulic accumulators that are used to get the JFS system to run. This is just a gas turbine, and it uses the same fuel that the airplane burns. And in order to get it to run, it uses accumulator pressure, and I guess that's to get the turbine up to speed so that you can introduce air and fuel and spark and get it to run continuously. But once you've positioned this switch to start, in other words, you either right click it or accidentally left clicked it, you have shot your wad here. You've used the hydraulic pressure in those two accumulators. Because you were above 20,000 feet, it never started, but you used the accumulator pressure. Now you've got no way to recharge this system. Normally, the B system pressure will recharge those two accumulators in about 40 seconds, but because we're on EPU power and we've lost the B hydraulic system, we have no way to recharge the accumulators. So there's no way that you're going to be able to get this engine started. You might as well punch out now. So that all occurred because you didn't wait until you were below 20,000 feet and you used the JFS system. Alrighty. So we're below 20,000 feet. Let's correct the situation that caused this engine flame out. So we fly in the airplane, we analyze the situation, we have a fuel system problem, the engine flamed out, we correct the problem. I'm going to come off pause and correct the problem here. And now we're going to start the JFS going with a right click. And that starts the spool up sequence. Now it takes quite a long time for the system to start to spool up. Just now, nope, not yet. There we go. Just now it's starting to spool up. So it takes about 30 seconds to get this RPM up to 20 to 22% where we can start the engine. Alright, so we've corrected the fuel situation. What I want to do is I put the throttle in the mid-range, and then when I get 22%, I'm going to click the throttle idle detent right about there, click it, pull the throttle back to idle, and now the engine will spool up. And it's going to take another 30-35 seconds or more to get up to 70%. You don't want to advance the throttle, just leave it at idle in this situation while the engine relights. And everything comes back in just the reverse order that you lost it. Now once I get over 30% on the RPM, I can actually decrease my speed to 170 or something lower than 250 to help preserve altitude. So here comes 70%. Now that's flight idle. Now I can advance the throttle. I'm going to clear those fault messages, and in order to regain control of the radios, I go back to the CNI switch, put it in the up front control position, and I could leave this mode switch in guard, but I'm just going to put it back to preset. And now I've got both my radios working again. Now back on the EPU panel, I see that the EPU is still running, and it's running in the air mode. So anytime the engine RPM is above 80%, the EPU runs off of engine bleed air. But I don't need the EPU on at this time. I'm not burning any hydrazine. I'm using engine bleed air, but still proper form or checklist procedure would be to turn the EPU off. Now let's go back over to the EPU gauge, fuel gauge, and we can see that we lost a little bit of hydrazine. We burned hydrazine. So while the engine was starting up, we were less than 80% on the RPM, so we were burning hydrazine. And that's why we have a lower hydrazine fuel level indication. Alright, so that is how you do the JFS start. You have to be below 20,000 feet, and you have to be between 250 and 400 knots, the book recommends. Now, one additional thing is we pulled the throttle to idle, and then we did the JFS right click. If we do everything right, but we have the throttle all the way full forward in order to view the JFS start switch, and we tried to right click it, nothing would happen. So the throttle has to be back here toward the idle position. Alright, the next thing we want to do is talk about a spool down air start. And the spool down air start is what we're looking for is we want to initiate the start sequence before the RPM decays below 22% RPM. Should be easily done. We're going to get the same indications when I shut off the fuel. We're going to get all the indications that we talked about, but we're going to be right on top of our game here. We're going to see that we're below flight idle. We're going to put the power up to the mid-range. We're going to activate the throttle idle detent, in this case with the HOTUS button, and then pull the throttle back to idle and get a relight. So that should happen fairly quickly. So let's do that. So there goes the fuel. I'm going to correct the situation by opening the fuel valve again, turning it on. The RPM's decaying, the throttle is up mid-range, idle detent, and then pull the throttle to idle. I didn't mean idle detent, I meant throttle idle detent. And then pull the throttle to idle, and now the engine is winding back up. Now you can do this at any altitude below 30,000 feet. Now we've got flight idle. I can advance the throttle. Don't advance the throttle until you get a flight idle indication of 70%, and then advance it. Now I'm going to clear these fault messages, and I'm back in business with the exception that I'm going to come over to the, oh, it's already off. Yeah, we never did activate the EPU. Alright, cool. Alright, lastly, let's zoom up here to 30-something thousand feet. I'm going to put the sim on fast forward. I'm going to get up to 30,000 feet and do a windmilling start. And the windmilling start takes a lot of altitude loss. It's we're going to have about 30 to 35 degrees of nose down pitch attitude just to get the RPM gauge to come off zero. It's not going to come off zero until we're about 400 knots in the descent. And then we're not going to get 20 to 22% until we get about over 500 knots in the descent. Alright, we're back flying here. Autopilot's on at 34,000 feet. And I'm going to shut the fuel off. There's the RPM decay. I'm going to close the fuel valve again for the relight. And I'm going to let the RPM go all the way down to zero just to show you a worst case scenario. Okay, there comes the EPU going again. Now because I'm going to do a windmilling RPM start, I want to jettison these external stores that I have. So this is still available with EPU power. So there goes all the external stores. So we got a slick wing. Alright, there's zero on the RPM. We're at 34,000 feet. Let's push it over to about 30 degrees or so, 35 degrees nose down. And now we're just waiting. We got to have 410 knots or so to even get an RPM indication. Alright, there's some RPM. I'm going to shallow out just a little bit as the speed increases. We're going to get about 500 knots. Let's make sure we have the fuel valve in the correct position here. Coming up on 22, mid-range on the throttle, idle detent, throttle to idle, and there's the restart. Now I want to trade this altitude. Anything in excess of 250 knots, I want to trade airspeed for altitude. So we got down to 8,000 feet or so. So I want to zoom back up here and get some altitude below me in case I have to do another restart for some reason. Alright, a little more zoom would be good. It takes quite a while. It takes about 30 seconds to get to 22%, and then another 30-35 seconds or so to get to flight idle, which is 70%. So everything comes back on in reverse order. Get a 250 knot glide. Actually, I can do lower than 250 since I've got a good engine. And now I can bring the throttle up and get rid of these messages. Put the auto throttle on. Let's come back over to the left side panel and notice that the EPU is still running. It's in the air mode because I've got more than 80% RPM. It's using engine bleed air. If I had less than 80% RPM, it would be using hydrazine as its fuel source, operating source. But since I've got more than 80%, the hydrazine is off and air is illuminated. Now when the RPM goes below 80% and the hydrazine light comes on to tell me I'm using hydrazine fuel, the air light still remains on. It'll always be on until I turn the system off. Alright, so I'm going to come back over and turn off the system here. Alright, I've got a master caution for what? I don't know. Oh, fuel stores. Okay. We'll go down here and take care of that real quick. And that will extinguish the master caution light. Okay. The last consideration here, the last engine start that I want to do is at low altitude. So let's get down in the weeds here. And when you're at low altitude, you really don't have a lot of time to get the engine restarted before you hit the ground. So it's going to take 3,000 or 4,000 feet of altitude to get this engine restarted. So they suggest that as soon as possible, immediately you get the JFS switch going. So we're doing 400 knots, we're in the weeds. I'm going to shut off the fuel, and then I'm going to correct it. I'm going to roll wings level and zoom, trade some of this airspeed for altitude, and immediately come over and get the JFS switch to the on position. Alright. And then I'm going to advance the throttle, do a throttle idle detent, and then throttle to idle. And so that system worked. If it didn't work, then I would have to use the complete the JFS start sequence. That time I used the spool down sequence for the engine start, and unfortunately it worked. If it didn't work, then that's why I have to immediately get the JFS switch on so that I could get the RPM back up to 22% and get the engine started before I lost too much altitude. Alright, so everything's come back on. I clear the faults and advance the throttle once I get 70%. Put the autopilot on, come back over, turn off the EPU, and make sure I have no fault lights, and I'm back in business. And I think that's everything I wanted to talk about. So it's very important. The key points here are you have to be below 20,000 feet to get the JFS switch to come on for your engine start. You have to have the throttle at idle and right click that JFS start switch before the JFS will run. Alright, I think that's everything I wanted to talk about. I hope this helps somebody, and trip out.